All right, we're going to take what we learned about law of sines and we're going to apply it to some word problems. With any word problems, know that you are going to need to annotate them, set up a picture, and then an equation and solve it. So let's start with annotating this one. I'm going to start with problem number 1. And for this video, I'm going to do 1, 2, and 3, and then I'll do another video for some more problems. All right, angle of elevation of a TV tower is 65 degrees. From a point 42 feet further away, the angle of elevation is 52 degrees. And the final question is, how high is the tower? Okay, it is not going to be important how good your artistic skills are. That's never going to be a concern of mine, but you absolutely need to make sure you get this information in the right place. So this is where I'm going to draw my little TV tower. Okay, I'm not going to worry about decorate. It doesn't matter. Okay. Angle of elevation is 65 degrees. So at somewhere further away from the tower, all right, I don't know where this is, or no, there's going to be a right angle though, simply because I'm going to assume, and this is an assumption you can make, that TV tower is going to be built perpendicular to the ground. That's what I'm going to assume. So somebody on the ground is looking up at the top of the tower. So let's go ahead and draw that in. And this angle right here is 65 degrees. Okay, that's what the angle of elevation is. Now it says from a point 42 feet further away. So this person right here, whoever's looking up at the tower, is going to back up 42 feet. Okay, so back that up 42 feet. So from here to here is 42 feet. Now the angle of elevation is this angle right here, and that's 52 degrees. Okay, so the question is, how high is the tower? So this, remember, was our tower over here, so that's my x. Now what I'm going to do is I'm actually going to zoom in just on the picture because that's going to be what my focus is now. I don't need to worry about the word problem because I have filled in everything I can. All right. So I'm going to I have a calculator sitting next to me, and I can pop up Desmos or Calculate84 if I need it. Okay. So the big thing I want to do is I recognize I have a right triangle here. I have a non-right triangle here, and then I have a big right triangle. Unfortunately, I don't know enough to use the big right triangle or the little right triangle to find x. I just don't have enough information. So I need to find some more information. One of the big things that I would highly recommend you do is once you know some of these angles, this is a 65 degree, we've got a little 52 degree angle down here, fill in the rest of the angles. Okay. So in the little original right triangle I drew, I have a 65 degree angle here. Using the fact that there's 180 degrees in a triangle, I can tell you that this upper angle is 25 degrees. I know that this 65 degree angle and the angle adjacent to it form a straight line. So these two have to be supplementary to each other. They add up to 180. So 180 minus 65 gets me this little angle right here. I'm saying little, but it's an obtuse angle. Is 115 degrees. And now that I know this 115 and this 52, I can figure out this upper angle right here. So let's see, 180 minus 115 minus 52. This itty bitty angle right up here is 13 degrees. Now, what do I want to figure out? Well, I would say either figure out this hypotenuse for the big right triangle or this hypotenuse for the little right triangle. It really won't matter. For giggles, I'll do the big angle right here. Okay, so let's say I want to find that x. Actually, no, I don't want to call it x. Let's say I find h for hypotenuse. That'll work. Now, the reason I want to do this is this obtuse triangle right here. I now know all three of my angles. I know one side, and I want to know another side, which means I can apply law of sines here. Once I know this hypotenuse, I can use the big right triangle to use right triangle trig to find x. So that's kind of how this is going to work. So let's find h. And let's see, we've got sine of 115 over h equals. Now, this side down here is 42 feet, not 42 degrees, 42 feet. And it is opposite to this 13-degree angle. So make sure you match those up. So that's going to be sine of 13 over 42. So I'm going to do some cross multiplication here to solve for h. So h sine of 13 equals 42 sine of 115. So h is equal to 42 sine 115 over sine of 13. So I'm going to go ahead and throw that into my calculator. Actually, let me go ahead and pop up, of course not. Take a second here. Let me grab Calculate 84. Okay, so let me clear all that out. Go ahead and put, there's a split screen I want to do. There we go. All right, get that set over. All right. So let's go ahead and throw this into Calculate 84. And the reason I'm going to use, it doesn't matter if you use Calculate 84 or Desmos. I do want to remind you, I've said this repeatedly, please make sure you are in degree mode. I noticed a few of you in the class kick assignment were working in radian mode, and you, in some cases, were getting some really wacky answers, and in some cases, whoops, one too many, one. In some cases, you may not have actually known that you were in radian mode, which is a problem. All right. So let's see, this is my numerator, 42 sine 115, and now I'm going to divide by sine of 13. So sine 13. Okay. Now h is equal to 169.214 stuff. Okay. So this is one of the places where I'm going to make my calculator do a lot of work for me. I am actually not going to round this off. So what I'm actually going to do is set up a problem with h in it. And wherever I have h, I will use this answer. And I'll show you how that works in just a second. Okay, now that I know this hypotenuse, I'm going to ignore all this stuff inside, and I just want to work with this 52-degree angle here. I know my hypotenuse and my x value. So if this is my reference angle, this is opposite, this is hypotenuse, we're going to use regular sine here. So sine of 52 is equal to opposite, which is x, over hypotenuse. So x is going to equal whatever h is, which remember is this 169 point whatever, which is still sitting in my calculator, times sine of 52. So in the calculator, all I'm going to do to get this answer is just hit times. And if you notice, it'll just say A and S. And this actually works in all of the TIs. That's just going to take your last answer and do whatever you need to with it. In this case, times sine of 52. So my tower here is 133. Let me take a quick look. Okay, if there are no directions about rounding, round to 2 decimal places, please. So 133.34 units are feet. So our TV tower is 133.34 feet. All right. So this is going to be where law of sines is going to be useful in terms of kind of figuring out these multi-part problems. All right, so that's problem number 1. All right, I'm going to go ahead and go on down to problem number 2. I am going to close out Calculate 84, just to make it a little easier to see the problem. All right, so problem number 2, I'm going to annotate it first, then draw my picture. So two people 60 feet apart are on opposite sides of a tower. Angle of elevation of the top of the tower from one person is 39.6 degrees, and from the other person is 27.4. Find the height of the tower to the nearest 1/10 of a foot. Okay. So here's the thing. We have a tower. We have two people who are on opposite sides of the tower. These two people are 60 feet apart. One person is looking up at the tower and has an angle of elevation. So this angle right here is 39.6 degrees. The other person is 27.4 degrees. And we're going to assume the tower is perpendicular to the ground. Now, what we want to find is the height of that tower. So I'm going to zoom in on the picture. All right, so I've zoomed in my picture. Unfortunately, this 60 feet isn't for this right triangle. It isn't for this right triangle. It's for the big triangle here. So what I'm actually going to do is figure out this angle right here, okay? Because that will then let me use this angle with this side, all right? These two are opposite to each other. And then I can use either of the two little triangles and figure out what that height is, or that hypotenuse is, to use it to find x. So let's start by finding out that orange angle I marked. So let's see, 180 minus 39.6 minus 27.4. Whoops. Put the wrong thing in my calculator. All right. So this angle right here is 113 degrees. Now, is it going to matter if you find the hypotenuse on the left here or the hypotenuse on the right? Absolutely not. Pick one of them. So I'm going to pick the one over here on the left. It won't matter. Whoops, I don't want to call it x. I keep doing that, sorry. Let's call it h. H for hypotenuse. So in this case, I am going to use this angle, 113 degrees, with its opposite side of 60. And I'm going to use this angle, 27.4, with its opposite side of h. That's the law of sines I'm going to set up. So let's see what we've got here. Sine of 27.4 over h equals the sine of 113 over 60. Solve for h. So h sine 113 is equal to 60 sine of 27.4. 60 sine 27.4 over sine of 113. That is a horrible 113. Hold on. There we go. All right. At this point, I'm going to pop back up. Maybe I'm going to pop back up. Calculate 84 here. All right. So clear out what I have. Not that that matters really. Now, one thing you'll notice that I forgot to say the last time, please put the numerator in parentheses in your calculator. Because you want to make sure that you have the entire numerator put together divided by your denominator. Or you can put in the numerator, hit enter, and then divide by the denominator of sine 113. All right, so this is, all right, 29 point, a whole bunch of nines there and some more stuff after it. All right. Now that I have found this hypotenuse, I'm going to use this left side of the picture and just focus on the right triangle. So I know this angle, I know its opposite side is x, and I know the hypotenuse, so I can set up a regular sine problem here. So sine of 39.6 is equal to opposite of x, or is x, over the hypotenuse of h. So let's see. X is equal to h times the sine of 39.6. So that means I am going to take this H value, which is sitting in my calculator, all right, 29.99, times, and this way the calculator will hold all those decimal places, sine 39.6. Go ahead and hit enter. Find the height of the tower to the nearest 1/10 of a foot. So that means I just want to round to one decimal place. So the tower is 19.1 feet. Okay. I'm going to go ahead and just close. Can I close that over some more? Nope, it's just going to go away. All right. All right, last problem for this set is going to be problem number 3, and then I'll do, like I said, I'll close this video, and I'll do something else or a different video for the rest of the problems, or some of the rest of them. Okay, a flagpole 35 feet high stands on top of a building. Okay. From a point on the ground, the angle of elevation to the top of the pole is 52 degrees. And to the bottom is 43 degrees. Find the height in feet of the building, rounded to 4 significant digits. Okay, let's draw a picture. So here's the idea. We have a building, and on top of the building is a flagpole. All right. Now, we know that the flagpole is 35 feet high. Okay. Now, when it says a point on the ground, just literally pick a point on the ground, okay? We're going to assume that the building was built perpendicular to the ground. Okay, this is not the Leaning Tower of Pisa in this problem, and if it was, I would tell you. The angle of elevation to the top of the pole, now this is where I'm going to actually take out some of a pretty picture here. I'm going to take out the, I'm going to take out the actual flag. Hold on a second. That looks awful. All right, there we go. And I'm going to slide the 35 to the other side just so I'm not confusing myself in the picture. So 35 feet for the pole. Okay, so to the top of the pole is a 52 degree angle, right? That's the angle of elevation. And to the bottom of the pole, I'm going to put that further in the picture, is a 43 degree angle. Okay. Find the height in feet of the building. So we want to know X, all right? How tall is that building? All right. First thing I'm going to do is go through and mark a bunch of the angles out. Okay. Now I'm going to slide X over just a bit, because basically what I'm going to do is put a little dotted line here. Okay. So let's see. If this angle is 43, we know that this is the 90. This little angle up here should be, I believe, 47. And it is. Okay, so let's go ahead and mark this angle as 47 degrees. This angle and the one right above it, these are adjacent angles. So we're going to do that. These are supplementary. 180 minus 47. This angle right here is 133 degrees. Then we can figure out this angle. Now you want to be careful, okay? Because this angle right down here, I'm going to mark it in, I don't know, I'll highlight it in red here. That angle is not 52 degrees. So you want to be really careful. This angle is actually, the whole thing is 52, okay? And so you just need to be careful of which angles you're dealing with. So I'm actually going to split this off. This is a little, whoops, let me get back to a pen here. This little angle right here is going to be 52 minus 43. So is that 9? That is a little itty bitty 9 degree angle. Okay. So now if I look at the obtuse triangle here, the 9 degree, the 133, and then if I do 180 minus that, this angle up here is 38 degrees. All right, we've got all the angles labeled. We've got all the angles listed. one of the easiest things is going to be if we're looking for x here, x is part of the little right triangle down here. It would be very helpful if I could find its hypotenuse. So that's what I'm going to find. I am going to find h. Okay. Now, let's see if I can figure out which pieces to use. H here is opposite to this 38-degree angle. This 9 degrees is opposite to that 35-degree angle. So those are the pieces I'm going to use to set up my law of sines. So sine of 9 over 35 is equal to the sine of 38 over h. So let's see, this would be h sine of 9 equals 35 sine 38. H is equal to that numerator divided by sine of 9. Okay, back to Calculate 84 I go. There we go. Clear it out. So the alternate way to do this, if you're unsure about the parentheses or you forget them, or you tend to forget them, just put this numerator in, hit enter, and then immediately divide, whoops, take that away. There we go, divide by sine of 9. All right, so I am getting an h value here of 137.74 and some more stuff after it. All right, now that I know this hypotenuse, I can work with finding x using just the little right triangle. So let's say I go with this 43-degree angle, x is opposite, I know the hypotenuse, I'm going to set up a sine problem. So let's see, sine of 43 is equal to x over h is the hypotenuse. So x is going to equal h sine of 43. Remembering that h is sitting in my calculator, I'm going to hit times sine of 43. And let me see if there's any, give your answer to round it to 4 significant digits. So basically, if I remember my significant digits correctly, 93, keep it simple, round it to 4 decimal places. If you're sitting in a science class and they tell you to do something different with significant digits, believe them. The significant digits is not going to be significant in terms of answering this problem. So if it says 4 significant digits, round it off to 4 decimal places, please and thank you. All right, I'm going to go ahead and close out Calculate 84. Let me double check that I didn't do anything goofy with this answer. Should be good to go. All right, these are some examples of how you use law of sines. And if you notice, in every single case in these word problems, we've been setting up 2 triangles, which technically makes 3 triangles, but that's a different problem. But we've been setting up multiple triangles here and using law of sines to find something and then right triangle of trig to find something else. As always, if you have questions or concerns, please, please, please ask. All right, you have the ability to send me an email message. You can send me a Canvas message. And of course, you can ask questions in the Zooms. So please let me know if you have any questions or concerns.